Today's topic is on finding cube roots. So we're going to find the cube roots of perfect cubes and evaluate expressions involving cube roots. A cube root is kind of like a square root, except you're looking for what times itself twice will give you another number. And just like square roots, perfect cubes are those numbers whose cube roots are integers. For example, if we have 2 cubed, that is 2 times 2 times 2, which is 8, which means the cube root of 8, we're saying what times itself twice will give me 8. And I know that that's 2, so the cube root of 8 is 2. And so that's a perfect cube because our cube root is a whole number. It's an integer. Our first few examples, we actually just did find the cube root of each number. So we have to ask ourselves what times what is going to give us 8. And sometimes it's really easy to, it's smaller numbers, you can kind of guess. But one way that always works for cube roots is you can find the prime factorization of a number. So we know we have to say what times what's going to give me 8. 2 times 4, and 2 is prime. What times what gives me 4? And it's 2 times 2, and both of those are prime. After you do your prime factorization or your factor tree, then you're looking for 3 groups because cube roots are all about groups of 3. Well, if you look, we have 3 different groups. Here's a group, here's a group, and here's a group. And within all of those groups is just 2. So the cube root of 8 is 2. Now, whenever you look at B, we have a negative cube root. So unlike square roots, we can have a negative under this radical sign because you can end up with a negative answer. If you have a negative times a negative times a negative, negative times a negative is a positive, but you multiply it by that negative again, which will make your answer negative. So if we erase what we did over here for 8, now you can do the prime factorization on this also. So we're doing negative 27. So I'm just going to do the prime factorization of 27, and we're going to know that our answer is going to have to be negative. So I know that 3 times 9 is 27, and remember in your factor trees, you're circling all the prime numbers. And I know that 3 times 3 will give me 9. And so again, you're looking for 3 groups. Once you get all those prime numbers, I have a 3, and a 3. And so here are my 3 groups, and within each group is just the number 3. So I know the cube root of a negative 27 is negative 3. So on C, we're doing the same thing. We are looking for a cube root, but this time it's a fraction. Now, when you have fractions, we're going to do the same thing as square roots. We're going to look and see, are these both perfect cubes? And I'm just going to go ahead and tell you, I know you probably don't know, but 64 is a perfect cube. So we're basically doing the cube root of 1 over the cube root of 64. And so we know whenever we're looking at this, we don't have to do the prime factorization of 1 because I know that the only 3 numbers I can multiply to get 1 are 1. 1 times 1 times 1 is 1. So when I'm looking at 64, I come over here to do my prime factorization, and I know that 2 times 32 gives me 64. And I know to get 32, I can do 2 times 16. And I know to get 16, I can do 2 times 8. And the factors for 8 are 4 and 2. And the factors for 4 are 2 and 2. And you can see we have lots more numbers than we did on the last couple. So you're still looking for those 3 groups. And so here's a group, here's a group, and here's a group. And I don't know if you notice, all of our groups are even. We have 2 2s in each group. Well, when you multiply that out, 2 times 2 is 4. 2 times 2 is 4. 2 times 2 is 4. So essentially what we're saying is 4 times 4 times 4 is 64, which means that 4 cubed is 64. My pen's going to stop writing all of a sudden. Which means these are opposite, because remember, cubes and cube roots are just like squares and square roots. They're inverse operations. So I know the cube root of 64 is 4. All right, and just like I just said, just like squares and square roots, cubes and cube roots are inverse operations. They can undo each other, just like addition, subtraction, multiplication, and division. So whenever we start evaluating with square roots, on A, we have 2 times the cube root of negative 216 minus 3. So the first thing we need to do is figure out what is the cube root of negative 216. So I know my answer is going to be negative. I'm going to go ahead and write that down so I don't forget it. So I'm going to come over here to the side and I'm going to do my prime factorization of 216. So I know that 2 times 108 will give me 216. And 2 times 54 will give me 108. And 2 times 27 will give me 54. 27 is 3 times 9. And 9 is 3 times 3. Now, this is not the only factor tree that you can get. 216 is also divisible by 3. So your factor tree may look a little bit different than mine. But that's okay. We'll get the same answers in the end. So if you'll notice, I have 3 2s and 3 3s. So whenever I start making my groups, remember they've got to be even. So here's a group that has a 2 and a 3 in it. Here's a group that has a 2 and a 3 in it. And here's a group that has a 2 and a 3 in it. And so you multiply out what's in your group. 2 times 3 is 6. So I know that 6 times 6 times 6 is 216, which means the cube root of negative 216 is negative 6. Then you just pull everything else down. You pull your 2 down and your minus 3, and you follow the order of operations. 2 times negative 6 is negative 12, and you're subtracting a 3. Remember, we can change the minus to a plus, change the sign of next. Negative 12 plus negative 3 is negative 15. Now, some of these cube roots are going to be like square roots. You're just going to start memorizing them the more you use them, and so you won't have to do the prime factorization every time whenever you start memorizing these. Now, look at B. We have the cube root, but then we cube it. So if we take the cube root and then cube it, those are inverse operations. So they actually just cancel each other out. So we end up with 125 plus 21, which is 146. So anytime you see it by itself, you just do the prime factorization and find the cube root of it. Anytime you see the cube root cubed, they just cancel each other out. Now I'm going to let you pause the video, try to work these out, and whenever you're ready, unpause it, and we'll see what you got. All right, for number 1, the cube root of 1 is 1, because 1 times 1 times 1 is 1. Number 2 was a little bit more difficult. 343 is kind of hard to find something to go into it, but you should have gotten negative 7. Because negative 7 times negative 7 is negative 343. On number 3, you're going to do the cube root of 27 and the cube root of 1,000, and you're going to make your final answer negative. So you should have got negative 3 over 10. On number 4, when you start evaluating these expressions, the cube root of 8 is 2. Follow the order of operations. 4 times 2 is 8. 18 minus 8 is 10. On number 5, the cube root and the cube cancel each other out and leave us with a negative 64 plus 43. Remember, different signs subtract. Take the sign of the larger number, so you end up with negative 21. Number 6, we have the cube root of 512, which if you do the prime factorization, you'll find out is 8. Then you just follow the order of operations again. 5 times 8 is 40, minus 19 is 21. Now, on our last example, we're going to do evaluating an expression. Remember, this is just an expression because there's no equal sign in it. We just have x divided by 4 plus the cube root of x divided by 3. It's not equal to something. We're not having to solve an equation across the equal sign. So what we're going to do with this is they tell us that x equals 192. And so we're going to plug that 192 into our expression. We have 192 divided by 4 plus the cube root of 192 divided by 3. And if you'll notice, that cube root is over that whole entire fraction. So we know we can go ahead and simplify 192 divided by 4, and you can actually go out to the side, do some long division, and figure out that it is 48. We're going to bring our plus sign down. So when you have these fractions, you have to look at it and you have to ask yourself, are 192 and 3 both perfect squares? Well, I know 3 is not a perfect square. There's no number that I can multiply by itself twice to get 3. In that case, go ahead and divide this out. Bring your cube root down and figure out what integer this is. And so 192 divided by 3 is actually 64. Now we can use some knowledge we've came up with previously. We already figured out that the cube root of 64 was 4. And so if you have forgotten it, you can go over here and do your prime factorization again. And we know that 48 plus 4 is 52. And so when we evaluated our expression, we got the answer of 52. All right, go ahead and pause the video for a minute. Try number 7 and number 8 and see what you can do. Okay, on number 7, I want you to notice that this 64 that goes in for y is under the radical sign also. So we actually end up with the cube root of 8 times 64 plus 64. So you've got to do this 8 times 64 first, which will give us 512. The cube root of 512 is 8, and we've been bringing our plus 64 down the whole time, and 8 plus 64 is 72. Now on number 8, we've got 2 times 3 plus the cube root of 9 times negative 3. And I see that when I was typing this out, I made a mistake. That's not a negative 2, is it? That's a positive 2. So positive 2 times 3 give us a positive 6. Bring our minus sign down. Keeping our cube root, 9 times negative 3 is negative 27. And so the cube root of negative 27 is negative 3, and it looks kind of crazy because we've got to bring this minus sign down, and we're going to fix my mistake and make that a positive 6. Now, whenever we change the minus to a plus, change the sign of next, we end up with 6 plus 3, which is 9. And that's it for cube roots. I hope that that made sense and that you learned something.